Chapter 2, Practical Geography. In the previous standards, we have studied the elements of a map such as conventional signs and symbols, scale, etc. In this chapter, we shall study an important element of a map, namely map projection. Map projection. The Earth is a three-dimensional body. However, while preparing maps, we have to represent it in the form of a two-dimensional figure. This is the main difficulty in preparing maps. One can overcome it through map projection. For this, the graticule, that is, the network of the imaginary lines of parallels and meridians is used. The method of drawing the graticule on a flat piece of paper is called map projection. For different map projections, the graticule can be drawn using of mathematical or graphical procedures. The choice of a projection depends on the purpose of drawing a map and the size of the region. In a map, it is necessary to show accurately different aspects of a region such as its shape, area, distances, and directions. However, maintaining accuracy in all these in a single projection is difficult. Hence, in different projections, preference is given to different aspects. Figure 2.1 shows different shapes of paper placed on a globe. They are flat, conical, and cylindrical. The types of projection according to the shape of the paper are zenithal, conical, and cylindrical respectively. The flat paper can be positioned at the pole or the equator or any other location between these two. An image of the graticule can then be obtained on the flat paper with the help of light. Map projections can then be drawn using the image obtained on the paper. Try this. Take a round bamboo or plastic basket and place a lamp below it. Try to get the image of the basket's mesh on a piece of paper. Change the location and the shape of the paper. Observe the changes occurring in the image. Isolines. A line on a map joining places of equal values is called an isoline. For studying a given geographical variable, such lines are drawn on a map considering the values of the variable. Isolines are preferred for maps showing physical attributes. Isolines indicate the distribution of variables like temperature, rainfall, pressure, salinity, etc. Isolines for these are called isotherms, isoheights, isobars, and isohalines respectively. When isolines are close to one another, it indicates a rapid change in the given factor. When they are far away from one another, they indicate a slow change. For example, the slope of land can be gentle or steep. See figure 2.3 and try to understand the relation between difference in slope and the distances between isolines. Contours. The isolines for elevation are called contours. The line on a map joining points of same elevation is called a contour line. These lines collectively give an idea about the shape of a landform. They also give us an idea about the slope of the land. Contour lines can be used to indicate the following types of slope. Look at the figures to understand the types of slope when you read the matter given below. See figure 2.3, which shows uniform gentle and steep slopes. Number 1. Uniform slope. Equidistant contour lines on a map indicate a uniform slope. Number 2. Gentle slope. When the contour lines on a map are far away from one another, they indicate a gentle slope. Number 3. steep slope. If the contour lines on a map are close to one another, the slope is steep. Number 4. Concave and convex slope. On a map, if the contour lines with higher values are close to one another and those with low values move far away from one another, it indicates a concave slope. As against this, if the contour lines with high values are farther away and those with low values are close to one another, the slope is convex. Representing data on a map using statistical information. In the 7th standard, we had represented statistical information on a map of Kolhapur district. This year, we shall prepare another map. The taluka-wise density of population, that is, Census 2001, for Ahmednagar is given in the accompanying table. You have to prepare a choropleth map using this data. Procedure. Consider the density of population of the different talukas in Ahmednagar district. Find the maximum and minimum values of the density of population. We can place the density values in the following 3 groups. Number 1, less than 200. Number 2, 200 to 400. And number 3, more than 400. Check the density of population of the talukas in the table alongside. Find the talukas that belong to the groups we have identified. You have to use 3 proper shades out of the 4 given below. Draw the district map given in figure 2.5 on a sheet of tracing paper. Use dark to faint shades for higher to lower density values. Give proper shades to different talukas on the basis of their density values and complete the map. Prepare an index and show the same in the map. This is how a choropleth map is prepared.